So in our last video, we started doing some curve sketching with the derivatives of a function. Let's try some more of these with some different types of functions. So let's look at a rational function here. All right, we want to graph this one here. And in pre-calc, we did some graphing here, but we graphed mostly when we could factor this guy. And so we can't factor this thing, this top part, if we try. I've tried and messed up. I did it in class and messed up. But you can't factor. Two numbers that add to -2 and multiply to 4 don't exist. All right? So, we can't factor it. Bummer. Well, we can take the derivative, all right? So let's take the derivative. And we use our quotient rule. Derivative of the top, 2x minus 2 times the bottom. Keeps jumping here. X minus 2 minus the top, x squared minus 2x times the derivative of the bottom. The derivative of the bottom is just 1, so I'm not going to write that down. Okay, and we have x minus 2 squared on the bottom. Let's clean that up a little bit. And for sake of time, I'm going to jump right to it. Should be minus 4x. And then we have a positive 4. Minus 4. Oh, the constants go away. That's nice. All right. X squared minus 4x plus 4 on the bottom. Okay. So we want to find some critical values. And so let's do that. Okay. Critical values happen when f prime of x is 0 or undefined. It is undefined at 2, and it is 0. If we factor the top here, we have x times x minus 4. Okay. In fact, let's go ahead and write that out. There's our factored form there. That will be a little useful to us. And so when x is 2, when x is 0, we have a 0 on top. When x is 4, we have a 0 on top. And 2 was our undefined point there. All right? So let's check some values here. We're going to plug in the derivative. When x over here is -1, plugging in -1, we get a negative times a negative on top. That's going to be positive on top. Plug in -1, you're going to get positive on bottom. And let's try something here in the middle. How about a 1? When we get a 1, we're going to get a, plug in 1, we're going to get 1 positive times a negative. This will be negative on top, and this will be positive. Bottom's always going to be positive, right? And so we plug in 2. Actually, let's go for a 3. 3's in between here. Plug in 3. You're going to get positive here, negative, so the whole top's going to be negative, and the bottom's going to be positive as usual. And let's plug in something like 5. 5's going to give us positive on top, and always going to be positive on bottom. So we see that this is going up and down, increasing, decreasing. We have decreasing still and increasing on this interval. This is going to be a max, and this is going to be a min, all right? And 2 is neither a max nor a min. So we can go over to our function here, our graph. Okay. Let's see. Can we tell an x-intercept? Let's go find f of that'd be a y-intercept actually. F of 0 is going to give us 4 over -2, and that's going to be a -2. So we have that. That's nice to know. And we also know that x does not equal 2. That's going to be an asymptote. So somewhere over here at 2, there's going to be an asymptote there, all right? And so we know that we have an asymptote. We know 0 is going to have a max somewhere. Oh, and we found 0. Look at that. All right, so 0 is a max. And we know at 4, we're going to have a min somewhere, all right? And so, come back. So somewhere we're going to have a minimum. We'll figure out where that's at in a bit, or get an approximation for that in a bit. Okay, let's find our second derivative just to find out what's going on here. So second derivative test, is going to give us our concavity. So let's go for it. And so let's go back up to this guy to take our derivative. We'll want to look at this thing. It's probably going to make life easier for our derivative because we need our quotient rule here. And so derivative of the top is going to be 2x minus 4. Derivative of the bottom, times the bottom, is going to be x squared minus 4x plus 4 minus the top, x squared minus 4x times the derivative of the bottom, 2x minus 4. All right. On the bottom, we've got this big ugly x squared minus 4, which let's go ahead and write that as x minus 2 squared. And we're going to square it again for our second quotient rule here. Okay, so, in the end, we just want this cleaned up. We just want it factored will be good, all right? So don't try to multiply this whole thing out. Let's take out this business right here. We got a common factor. Don't try to clean that up. Let's go ahead and factor that out of the top, 2x minus 4, because we need the top in factored form so we can find signs. That's what we need. So the leftovers will be this minus that, okay? So let's just deal with this minus that. The x squared minus the x squared goes away. Negative 4x minus negative 4x goes away. And you're going to have 4, and that's it. Okay, well, goodness, that sure cleans up nicely. All right, and the bottom is just x minus 2 to the 4th. All right, so let's find some concavity here. So in our number line for f double prime, okay, our critical values, we have, 2 is still a critical value because it's undefined. And then what makes the top 0? It looks like it's going to be 2. 2 makes the top 0, but 2 is undefined. So 2 is our only critical value. And so we find out that what happens is when we plug in negative, let's plug in 0, make life easy. Plug in 0 here. This comes out to be negative 4 times 4. That's a negative 16. Plug in 0 on the bottom. It's to the 4th power, so the whole thing becomes positive. So this is going to be negative. All right. Then let's plug in something like 3 over here. Plug in 3. We get positive on the bottom. We get positive on the top. So the whole thing's positive. So this is concave up, and this is concave down, all right? So to the left of 2 is concave down, and to the right of 2 is concave up, okay? So what that means, what does that mean for us? Well, we know that we're concave down on the left, so we know we're going down like this, okay? And we know we have this asymptote, so it's got to turn around at some point and come down, okay? We might find a 0 there, or even quickly consider if there is a 0, and we've got, look at the top over here, we got x squared minus 2x plus 4, so we might say, well, does x squared minus 2x plus 4 ever equal 0? You can't factor it, so we'd have to use the quadratic formula. X equals negative b plus or minus square root b squared minus 4ac. 4ac is going to give us 16 all over 2a, all right? Well, b squared minus 4ac right there gives us a negative number underneath, so that's an imaginary solution. So that means there's no zeros. Hey, that's good news. That's all we need to know. There's no zeros, so this never crosses the x-axis. There it goes right there. And that means the other one's going to look like this. Now, this is going to be concave up, okay? Now, how do I know it looks like that? We'll give you a little piece of information you may remember from, what was that thing called? Pre-calculus, that's right. So this is going to have some kind of slant asymptote, and we didn't find that. And this one that I'm drawing may or may not be accurate, okay? I don't exactly know the slope of that. We didn't take time to do that, but we just know it looks something like that, okay? What you need to know for the AP test is you need to be able to recognize this. It's going to be concave up here. It's going to be concave down here, all right? And so if you had to look at a graph and kind of connect it to some functions, by a quick look at the derivatives, that's the information we know. Okay, so that's good enough for us at this point in the game, all right? We're not going to take time. We would need some longhand division, by the way. Using longhand division, we could get that exact equation, that slant asymptote. We're going to stop this one here. Got two more we'll look at and post some videos about there. But there's a rational function. If your brain hurts, stop there. If you want a little bit more because you want to know about that slant asymptote, I'll go ahead and do that longhand division. In many cases, we don't need this. We just need to be able to recognize the function, the graph of the function here. So here's what we got. If I take x squared minus 2x plus 4, and I divide that by x minus 2, we get this. Longhand division, well, let's see. This can go in here x times, I want to multiply by x. Well, let me change colors. That'll look cool. So multiply by x, we get x squared minus 2x, and then we subtract, and that cancels out. That gives us 0. Bring down the 4, and, well, 4, you can't multiply x minus 2 by anything to get 4 because this is now has a lower degree. So what that means is this. That means that this is plus a remainder of 4 over x minus 2. So this function right here is another way of writing f of x. Okay? And we know as x goes to infinity, as x goes to infinity, this will just become f of x equals x, all right? And so our line there, I'm a little bit off with this line. Let's see if I can move that line. Nope, I can't move it. It's glued. So really, the slant asymptote is going through the line y equals x, and I'll kind of cheat there. There's the line y equals x, so our slant asymptote is there, and so this curve will approach that slant asymptote there. All right, so the blue curve is pretty close. Right here, it'll actually maybe flare out a little bit more than I graphed the first time. So that's how you find the exact slant asymptote. All right, so there you have it. But then again, as I said one more time, a lot of times, especially like on an AP test, something like that, you just need to recognize. We need to do a few calculations to quickly realize, hey, you know, it's going to be concave up, concave down. We can find that by the second derivative test. First derivative there will give us some max and some mins, and that's we kind of skipped that over. So the minimum should be over here at 4, and the max should have been here at 0. So this guy should have been the max there, all right? So I skipped over that a bit. All right. Good luck. Happy graphing.